Hi, my name is Jay Tedeschi, and I'm a Senior Technical Marketing Specialist at Autodesk. For the next 15 minutes or so, I'm going to be showing you some of the new modeling tools and updates in Inventor 2015. So with that, let's get started. Today we will take a look at what's new in Inventor 2015. We will begin with some of the core modeling tools which provide the user with a new workflow for advanced shape description, as well as enabling quick and powerful editing of model geometry from any source. We will also take a look at some of the enhancements which should appeal to almost every user, such as sketching improvements and changes to the assembly environment, which are focused on productivity when working with very large part count models. So with that, let's get rolling with our first example. The first thing we're going to take a look at today is an overall umbrella that we refer to as exceptional modeling. These are a pair of tools and techniques that essentially address issues with problem shape description. So these would be shapes which are very advanced, very organic in nature. We have a completely new suite of tools to address geometric issues or geometric models with these types of challenges, as well as a new workflow that we refer to as direct editing. These are some of the techniques that have been pioneered in our Fusion 360 tool. These same techniques are now available in Inventor, and they give the user a lot of capability with regard to making quick and easy edits of existing models, as well as addressing intelligent editing of models which are imported from other sources. Okay, so the first area we're going to take a look at is a set of tools that we refer to as freeform modeling tools. If we take a look at, a typically, um, I hate to use the word organic, keep using the word organic, but this is something that it's a term that is utilized in industry, and obviously this is a shape that is not orthogonal in nature. It's got a lot of blends, there's a lot of curves. And if we take a look at what was required to create a shape like this previously versus what the new freeform modeling tools enable in Inventor 2015, you can see here that there's a significant difference in the amount of work that has to be performed by the user to end up with the same shape. This customer VMech created this cover for the engine and transmission tunnel. And as you can see in Inventor 2014, this part required 74 features and was, I don't want to say the part was problematic, but it definitely took a while to create this part. Whereas now in Inventor 2015, with the freeform modeling tools, this same part takes exactly 7 features. Now, here are some examples of parts where the freeform modeling tools could be used to a user's advantage. These would be injection molded plastic parts. They'd also could be, for example, with regard to the seat there at the bottom, some hot wire cut. When you're using hot wire to cut foam, and or some other type of closed cell material which would be used for, that example is perfect. They'd be used for doing something like a seat, an automotive seat. In any case, these are good examples of where the freeform tools really are advantageous for the user. So let's now take a look at some of these tools in action. Okay, in this example, we're going to take a look at some techniques which could be used for creating a fender over the rear trailer assembly on the VMech 630. Now we're going to start with a couple of primitives. Now this is how freeform modeling works. You typically start with these primitive shapes. Symmetry can be used to enforce mirroring across symmetric planes. And in this case, we're going to use a feature which we refer to as bridge to join these two mirrored objects together. Now we're also able to do form editing. Now form editing can be performed on points, edges, faces, groups of faces, as well as entire selected areas on the model. Now as you can see, using edit form, we're able to, in this instance here, across a symmetric face, we're going to select a couple of points, and then those points are going to be affected utilizing a move triad, which should be familiar to users. This technique has been in Inventor for quite a while now. Um, as far as utilizing the primitives is concerned, let's take a look right here now. We'll do like a little tail light housing on the back end of our fenders. So what we'll end up doing is going into the box primitive, and then we'll locate the box where we would like to have it, the origin for it. Now you'll notice in the dialog box we select a number of faces, vertical and horizontal faces that we want on this new primitive, and you'll also notice that tangency is always enforced with these primitives. That's one of the advantages of using this technique, this modeling area in the software, is that you always are ensured of curvature continuity in your model. Now, previous tools that users had available to them, this sort of control was not easy to accomplish, and as you can see, it's pretty much automatic here in Inventor 2015. So we have the box shape. We just blended it into the rest of the overall fender. Let's go ahead and shell that out. It's a hollow plastic, obviously it's a plastic part of some thickness. Now we'll go ahead and punch out a shape. We'll cut the actual opening for the tires themselves, so the user has access to the hubs of the wheels. And now finally we'll return back to the top level environment, and you'll see very quickly we're able to go ahead and create this very organic and very blended shape. Hopefully this shows you some of the power of the freeform modeling tools available now in Inventor 2015. Now let's take a look at some of the direct editing tools which are incorporated into Inventor 2015 this year. Now these expand on some capabilities that have been in the product for a while now. Move Face has been in there for several years. This takes this to the next level. This technique, this direct editing technique, incorporates the same approach that's utilized in our Fusion 360 product, and goes one better, I would say. And the reason for that is because of the way we've implemented it into Inventor 2015 allows it to be used on both full-featured parametric models, as you can see here, as well as models which have their origin in some other product. These could be files which are step files. They could be IGES files. They could be files from other uh, design modeling products. Point being that these tools are very powerful now and can be used on both native Inventor models as well as models which are imported from other sources. The direct editing environment allows for a variety of changes to the geometry itself. As you can see here, faces and groups of faces can be moved, they can be sized, they can also be rotated and obviously deleted. They also, and here's where the real power comes into display. They also tie in directly with the parametric modeling environment. So changes that are made to features which have parameters which drive them, which, with regard to native Inventor files, that's pretty much every feature that you're going to touch. The direct editing environment works in conjunction with the parametric environment, in that changes that you make will update the parameters which are underlying uh, the underlying architecture of the features themselves. So the direct editing environment blends very, very well in with the parametric environment. One of the biggest advantages of working with the direct editing environment is when the user has to edit or change non-native data in the Inventor environment. This data can come from any one of a number of sources, and this is extremely advantageous when working with data, for example, from vendors. The VMEC data set is a very good example of this, as VMEC themselves source various components in the 630 from other vendors. For example, the motor and transfer cases, the transmission components are all sourced from Honda. Any changes that they needed to make to that model that they get from Honda can be carried out using this direct editing environment. Another advantage of utilizing direct editing is how well it integrates with the existing feature history when working on native Inventor components. Each one of the edits that is carried out, or each one of the edits, changes which is made utilizing the direct editing tools, is saved in the feature history. And with that, let's go ahead and take a look now at a couple of examples of direct editing. All right, let's take a look now at some of the direct editing tools in use. Here is the Honda GX620 motor that is supplied to VMech from Honda. And we have a muffler that VMech themselves create for this assembly. Now you noted before at the top level, or that motor assembly, that the exhaust manifolds didn't line up exactly. So we're going to go ahead and use some of the move tools to manipulate the position of the exhaust manifold flange. And now we'll go ahead and rotate that exhaust manifold flange. Now keep your eyes on the browser, because every single one of the changes that we make is incorporated into the feature history of this part. More importantly, the parameters which are being edited, as we manipulate this geometry, model parameters are being changed to suit those direct edit changes. Now, a more powerful, and I don't want to say more powerful, but a powerful use of these direct editing tools occurs when companies have to edit geometry that is non-native, data that comes from, for example, another company that you're working with on a project, or from a vendor that's supplying you with some components. And as you can see, this native step geometry, we're able to essentially go in and make these very profound geometric changes. Changes such as the height of this boss can be referenced from, we basically, instead of just doing a blind stretch, we're able to reference the distance from some neighboring geometry. You'll also notice that when we want to make a change to a group of faces here, we only had to select a single face, and the conditions, those tangency conditions which exist on adjacent faces, are maintained. We also have the ability of deleting existing geometry. So for example, if we wanted to put in bigger holes using actual hole features in Inventor instead of just changing the diameter of those 4 holes, we can just delete the existing ones and then put new holes in. Now another great capability is the ability of grouping components or pieces of geometry together. So for example, if we needed to change the angle of this circular array of holes, we just isolate those holes themselves, then select the axis that we wish to rotate them on, and then go ahead and rotate it. This is a very, very powerful set of tools now to the Inventor user. All right, let's take a look now at some of the changes which have been made to the sketching environment. First and foremost, you're going to notice that the constraint settings dialog box has been changed to allow for the addition of the new relax mode, which we'll get into in a second, as well as changes to the general tab itself and the inferencing. We've made changes to how constraints are set. We've made changes to the inferencing itself. We now display the sketch constraints themselves as you're creating them. You can select them, and basically manipulating those constraints has become much easier to the user. Now here's an example of the display on creation. Obviously the distance and angle, those have always been displayed, but now you'll see the addition of the coincident and tangent constraints being displayed as we are dragging our sketch geometry. Once these constraints are selected, we now also have greater control over how we manipulate them. For example, these constraints are selected, and then directly from the right-click menu now, we can delete constraints, as well as isolating coincident constraints and deleting those. Access to styles is now implemented within the sketch text functionality, and the inferencing environment itself has become significantly more user-friendly with the addition of the ability to snap to virtual intersections. Far and away, the biggest change to the sketch environment this year is the addition of relax mode. This is an environment which is turned on and off from the constraint settings dialog box, and it also has essentially the user can select which sketch constraints can be relaxed. So it's very, very powerful. I'll be showing you this very capability in a few moments when I do the demonstration. Now, here you see an example of what I was talking about. In this case, a couple of the constraints which we have filtered for being available for the relaxed mode changes are parallel and perpendicular. And you can see from the green geometry there is the geometry which is being moved, and conditions which are being overridden here are parallel and perpendicularity. So we've made these changes, but we're able to override these existing sketch constraints just through the use of this tool. And so with that, let's take a look now at a demonstration of the changes which have been made to the sketching environment. Okay, let's drill down in the assembly here. Not that one. Let's drill down in our assembly to the bracket for this the forward fog lamp or headlight. We're going to create a sheet metal part here. So we'll start by zooming down here. The bumper, the front bumper, let's just disable that. We really don't need that, and it'll be easier to see. So we'll activate our sheet metal component. I've already created it in place. I have a piece of reference geometry here. Previously created. I don't want to be redundant here. I just want to make sure that we show you the new the constraint settings and the changes that have been made to the sketching constraint environment, because it's very, very powerful additions now. So we'll start by projecting some geometry. We'll pick this edge, and you'll note that immediately we can see the display of the constraint. So this is locked. It's projected geometry, so the geometry itself is locked. Now let's go ahead and sketch a line. So go ahead, select create line. You'll notice that I can infer the intersection between the two. We'll pick that point, we'll drag it down, we'll snap to the end point. Coordinates constraint is created as well as a vertical constraint. Now when I try to grab this endpoint and drag it over, pop it on the end of the vertical line we just created, we can't do it because it is locked. So we'll turn relax mode on, and you can see that the filters are enabled for certain constraint types. And now when we drag it over, we will override that lock, and we'll create a new coincident constraint on the end of that line. We can also override that vertical constraint, which you see right there, and we change this now to an angled line. The vertical constraint is now gone. So let's go ahead and add an angular dimension between these two, and that's how we'll control this now. So put in 60 degrees. Now from here out, it's just, this is a straight contour flange, so there's nothing really ground shaking in that. Creating a contour flange is pretty straightforward, but hopefully you saw that the changes that we've made to the sketch environment now create a very, very flexible and user-friendly sketching environment. It's very, very easy to change what you've done. We really am proud. We're really proud of these changes that have been made to the sketch environment. Okay, last thing we're going to take a look at today are the changes which have been made to Express Mode, the Express Mode tools when working in large assemblies. We have enhanced this greatly from 2014 to 2015. And we've included the capability now to create components, sketches, work geometry. You can edit in place. You can pattern and mirror components. The assemble commands can be used. You can attach point clouds. You can create assembly sections of assemblies. And you have the ability of optimizing the loading behavior. So all this capability is now enabled in the Express mode when working in Express mode with large assemblies. So let's go ahead and take a look at exactly how that works. Okay, First and foremost, you'll notice we are in express mode here with this very large assembly. This is over 20,000 parts in this assembly. This is from Osgood. It's a food packaging machine, in this case yogurt with fruit. And this is the filling station right here. Now you'll note again, we are still in express mode here. Um, you'll note that some of the geometry is going to look a little rough. We have the display optimized for speed here. Um, but that's not a problem. So you'll note we have access to view sectioning. So I'll go ahead and set a view section. And let's go ahead and zoom in here on one of the components that we're actually going to edit. Again, all of this is now taking place in express mode. Last year, a fraction of what I'm doing right now was possible while you were still in express mode. Now, this is a huge advantage for customers that are working on medium to large data sets. So we've drilled down into this single component. We're now editing this component. Again, express mode. So let's go to, let's pick the hole. We'll edit the hole itself. Let's just change the size of that. So update to the hole size. Again, I'm going to point it out. Fourth time I've said it, still in express mode. So we edit the hole, all of the holes on all of these same components update to the entire assembly. Now we'll go ahead and finish the assembly and then back out. Again, I went over the changes that we made to the express mode a moment ago in the previous slide, but as you can see, I'm working on a very, very large assembly here, and the performance is, obviously graphic performance isn't great, but the fact is I am able to edit very quickly a 20,000 part assembly. Okay, let's take a look now. Let's summarize what we've seen today. We started with some of the tools which we were kind of putting under that umbrella of providing exceptional modeling capabilities. We looked at the freeform modeling tools, which are essentially enable the user to work with primitives, boxes, cylinders, and then take those primitives and manipulate the surface patches via symmetry tools, editing points, lines, edges, faces, groups of faces. A lot of capability there for for working with what we refer to as organic shapes. Then we took a look at the direct editing tools, which allow Inventor users to work with geometry from either native Inventor geometry or non-native geometry from other CAD tools. These are the direct editing tools are the ones where you essentially can just grab model geometry itself and then move it, delete it, rotate it, scale it. So any one of a number of manipulation types are available to the user in very, very natural and intuitive techniques for modifying that geometry. Next up, we looked at what we refer to as workflow enhancements. So the sketching improvements, most notably the addition of the relax mode. And then finally, we took a look at changes that have been made to the express mode for those customers that work with very large assemblies. I'd like to thank you for taking the time today to watch this video. We are really happy with Inventor 2015 and feel that we are on target with the changes we made this year. Hopefully you feel the same way and saw some things that appealed to you. I hope you have a great day, and again, thanks for your time. And again,